I've got a polynomial up here in factored form, and I want to use what we just learned about the multiplicity of our zeros to see if that can help me in sketching the graph. Okay, so I can see what my zeros are. They're just going to be the numbers that would make any one of these factors 0. So the number that would make this factor 0 would be -1. The factor that goes with that is x plus 1. That's the factor I just set equal to 0 to get that. And that's also x minus -1. The multiplicity is 2. And so now I'm just saying, what's the behavior at the intercept? Do we cross the axis or do we touch it? Because that's an even number, we just touch the axis. We will not cross it, so our function will not change sign there. Because the only thing that changes sign there is x plus 1, but I've got 2 of them. If they both change sign, that sign change cancels out. All right, if I look at my next factor, the number that would make that 0 is 3. The factor corresponding to that, of course, is x minus 3. And that multiplicity is 3. We've got 3 copies of that factor. 3 is odd, so we're going to cross the axis at that point. Because all 3 of my factors of x minus 3 will change sign, 3 sign changes aren't going to cancel each other out, so the entire polynomial changes sign there. My last factor is x minus 5. Of course, 5 is the number that would make that 0. Corresponding factor was x minus 5. And if there's no exponent, there's an understood 1. That occurs just once. 1 is odd, so we're going to cross the axis there. Now, if I go to graph things, I know at -1, since that's a 0, we've got an x-intercept at -1, 0. Similarly, we'll have an x-intercept at 3, 0, and 1 at 5, 0. Okay, so I've got those 3 points. Now I know we touch the axis here, but we cross here and here. But I do need to know, do we come down and touch and then go back up? Or do we come up and then go back down? Okay. When I use a number line to check for the signs, I know whether I'm above or below. Okay. So I need a little bit more information. I need a starting point. But I can get that if I combine this with my knowledge of the end behavior. So let's just write out, what's our lead term? Well, let's see. I've underlined, it looks like x is actually the lead term in each factor. Since I've got 2 copies of this factor, that's going to be an x squared. 3 copies of this factor, that's going to be an x cubed. 1 copy of this, that's just going to be an x to the first. That's a total of x to the 6th. So that's my lead term. So now that tells me that as x goes off to infinity, p of x is going to go to infinity. And as x goes to -infinity, p of x, doesn't equal infinity, goes to infinity. Goes to infinity. Same behavior on both sides. So that tells me to the left of -1, I've got to be positive because we're going off to infinity. Okay, so we're coming down. We'll touch the axis here, but we don't cross. So that means I've got to have some turning point somewhere between -1 and 3. Then we cross the axis here, turn and cross again at 5, 0. And notice there's a little bit of redundancy built in. I determined that my end behavior as we went off to infinity should be infinity. And simply by touch, cross, cross, that put me in the right place. So when I'm trying to get the general shape of my graph, 2 options. I need to find the zeros, but I can either use them to create a number line and sort of check the sign on the resulting intervals, or I can use the end behavior to know whether I start positive or negative, and then the multiplicities to know whether I cross or touch the axis. I often like to do both. I would often just create my number line here for -1, 3, and 5. If I did that, I should get that my function is positive, and then positive, and then negative, and then positive. And then I can just say, well, with the end behavior, yeah, I was supposed to start out positive. Since I was supposed to touch here, I wasn't supposed to change, it's still positive. Since I'm supposed to cross here, yup, it's supposed to be negative, and since I'm supposed to cross here, it will change to be positive. So I can sort of use one method and then use the other one to double check my answer. Okay. Now, if I just ask you to sketch a graph of a polynomial, does not matter to me whether you create a number line and check the sign or whether you use the multiplicity. I will point out that this number line is a skill that you are going to use an awful lot in calculus. So I would strongly suggest that you do at least some of the problems this way so that you practice checking intervals created by when a function is zero. Because you'll be doing that with things that aren't necessarily polynomials later on, and then this multiplicity trick doesn't work. However, the multiplicity is kind of important. I could ask you explicitly about that. So don't say, oh, I'm just going to use the number line. I don't need to know anything about multiplicity, because I could ask just a short answer question, what's the multiplicity of this zero? Okay. So you do need to know that, but you are going to need this skill as well. So don't use the multiplicity as a way of avoiding the number line. Do some of the problems with the number line, do some of the problems with the multiplicity. Better yet, use one method as your primary method and use the other method to just double check to make sure that you haven't made any careless errors.